This video explains about the correlation coefficient between a bivariate data. The objective of this video is to find the relationship between the two variables, which is the correlation coefficient for a bivariate data. And also the coefficient is represented by the value r, and we would like to find the equation and also find different methods of calculating r and also the facts about the coefficient. The coefficient r is a measure of the direction and strength of a relationship of the bivariate data. It is calculated using the mean and the standard deviation of both the x variable and the y variable, the response variable and the explanatory variable. And the formula for this is R is sigma I ranging from 1 to n of the product xi minus x bar by sx times yi minus y bar by sy divided by n minus 1, where x bar and y bar are the mean of x and y, sx and sy are the standard deviation of x and y. Now, if I would like to find the relationship between the two variables, I always make use of the scatter plot and the linear regression line. So in my first diagram, it looks like the line has a negative slope, and when the line has a negative slope, this coefficient, correlation coefficient, also will be negative. In my third diagram, it looks like the linear line has got a positive slope. So the coefficient will also have a positive sign. In my second diagram, which is in the middle, there is no relationship at all. Since there is no relationship, because the points are all scattered all over, it is hard to find the line of best fit for this. So there is no relationship at all, and hence the coefficient is also 0. Now the coefficient is always between -1 and +1. The strength of the relationship increases as r moves away from 0 towards either -1 or +1. So if it is closer to +1 or -1, it has a strong relationship. If it is coming closer and closer to 0, then it has a very weak relationship. If it is near 0, then it has a very weak linear relationship. If r is close to -1 or +1, that indicates the points in the scatter plot lie close to the straight line, and hence we say that it has a strong either a positive relationship or a negative relationship. If r is 1, then it has a perfect linear relationship. If r is -1, then also it has a perfect linear relationship, but in this case the direction will be negative, and when r is 1, the direction will be positive. The coefficient r has no units because since r is a standardized value of the observation, it will not change when we change the value for x and y. The correlations are calculated using means and standard deviation, so it is not resistant to outliers. The coefficient r is not resistant to outliers. Correlation makes no distinction between the explanatory variable and the response variable. So even if you swipe, even if you interchange the values of x and y, the value of r will be the same. It makes no difference which variable you call as x and which variable you call as y when calculating the coefficient. But when you are finding the regression line, we have to be careful about the x variable and the y variable. The properties of f r are: the calculation uses only standard units, so it is a pure number with no units. And r lies between -1 and +1. And for the extreme cases, when r is equal to -1, then the scatter diagram is a perfect straight line sloping down. When r is -1, the scatter diagram is a perfect line sloping up. Switching the variable x and y does not change the value of r, it remains the same. R is not resistant since R is calculated using means and standard deviations. And this diagram helps us to understand how to guess the value for R. In the first diagram, when R, since the values are all scattered, R is 0. In the first column, second diagram, it looks like it has a positive slope and approximately 0.5. The third one, it has a positive slope and the points are closer to a line, so it is approximately 0.9. And on the second column, first diagram, it looks like the coefficient, it has a negative slope and it is negative 0.3. Second one, the points are somewhat closer, it is negative 0.97. And in the last one, the points are almost lying on a line. So it has a strong correlation coefficient. It has a strong relationship, negative relationship, so negative 0.99. This video helped us to understand what the correlation coefficient is and how to compare the coefficients and what are the different properties of correlation coefficient are. Hope this video will be helpful to you. Thank you for listening and thank you for watching this video.